Last time we left off by creating a bar chart of Pokemon by their first type. I've performed some data wrangling to obtain a data frame with both first and second types in a single column. I've also created some variables to get the types in order of frequency and then plotted those counts in a bar chart. One thing that I'm interested in now is what proportion of Pokemon have each type. While I might be able to estimate this from the plot by knowing the total number of Pokemon, it's probably better just to show it directly in the visualization. One way of doing this is to use matplotlib to change the tick marks from labeling absolute counts to relative counts. Let's start by creating a list of tick positions. We start by computing the length of the longest bar in terms of proportion. The original Pokemon data frame gives us the denominator, and we use value counts to get the numerator. Now we use NumPy's aRange function to produce a set of evenly spaced proportion values between 0 and the max in steps of 2%, and store the values in the tick props variable. I'm also using a list comprehension to create an additional variable, tick names, to apply to the tick labels. These strings will show the proportions with a consistent 2 decimal places. Now we're ready to modify our plot. To change the tick locations and labels, we use matplotlib's xticks function. The first argument sets the tick positions. Since the counts are still an absolute value, we need to multiply tick props by the number of Pokemon to get their position correct. The second argument sets the tick labels. We need to use both arguments here since the positions and their values are different. Finally, we use the xLabel function to change the x-axis label from the default count to a more appropriate proportion. The resulting plot shows us that about 16% of all Pokemon include the water type, all the way down to only 4% that include the ice type. Alternatively, maybe we want to have the axis in terms of counts and use text on the bars to show proportion. This is where the flexibility of matplotlib can shine. We use a loop to place text elements one by one. The first argument to the text function is the x position, just after the end of the bar. The second argument is the y position, which starts at 0 and increments with the loop. The third argument is the string to be printed, the percentage. Finally, I'm going to add an optional parameter, VA, to center the vertical alignment of text on each bar. The final plot looks like this.